Hi everyone, for 6th grade Elevate Lesson 64, we are going to continue our work around calculating area. However, we are going to be working with composite figures. Composite figures are figures that are composed or made from other figures, such as squares, rectangles, and triangles. So, with that being said, I would love for you to launch students into a 1 minute turn and talk, asking them what similarities and differences do you notice between figures A and figure B. Students may say, oh, figure A is easy. We just got to do 5 times 4. Great. But then with figure B, you might see that students will say it's a little bit more complex. They have the same length, some may say, but our width is different. Some students may say, well, they don't have the same length because on one side the length is 5, but then on the other side, you can't really say that the length is 5. Here is 1, then you have maybe 3 here, and then you have another 1 here. Okay, that's 5. So students will engage in some discourse around how maybe finding the area for figure B is a little bit more complex than finding the area for figure A. And I don't want us to spend too much time going into how to solve figure B today, because I want us to jump into our model, which I think is going to provide students more clarity. This is tomorrow. But what you will say today is that figure B, finding the area for figure B is more complex. And what we would have to do in order to find the area for figure B is break up figure B into multiple shapes and find the area of each of those shapes and then add them together. For today, though, let me show you an easier example. So here's question 1. You're going to model for 3 minutes. I have a composite figure. It is not, I cannot say that this shape is a square, a rectangle, a triangle. It's not. There is no, it's an irregular figure. There is no name for this shape. However, what I can do is decompose the shape into 2 rectangular or square parts and find the area of each of those parts. So I can break it up like this and say, okay, well, that's 5 times 5, which gives me 25. And then I can find the area of what was left over, which is 3 times 2, which is 6. Okay, so now that I know that one part is 25 and the other part was 6, I can't just say, okay, the area is 25 and 6. No, I need to add it together so I can find the total area. So 25 plus 6 gives me a total area of 31 meters squared. Remember, we are carrying over the square units because we're not just multiplying the numbers, we're also multiplying those units together. So that's a great model. And so then you'll launch students into 10 minutes of partner practice time where they're decomposing the shape. I will say that there's not one right way to decompose the shape, okay? Some students may say, okay, I wanted to decompose it like this. This is my one shape in blue, and then in orange is my second shape. They have split it up very differently than how maybe I split it up in this exemplar. However, let's do the work. So in this example, although it is a little bit more complex, students can count the squares if they need to, but students will find that, I'm trying to get the right color. So this is 2, and then my length is 1, 2, 3, 4, 5, 6, 7, 8 meters. So 8 times 2 is 16 meters squared. And then for my orange shape, I have a width of 3 meters and I have a length of 5 meters, which gives me 15 meters squared. And then I would have to add that together. So 15 plus 16 gives me 31 meters squared. So see, it's the same answer, even though the second time I split it up differently than I did the first time. So there's no one right way to split up the shape as long as all squares have been accounted for. Okay. So you will launch students into 10 minutes of partner practice time. It's only 4 questions, and then 5 minutes for their exit ticket. They will get a point for getting the first part of the shape correct, then the second part of the shape correct, and then the last part is the total area. Please note that this exit ticket does not have any squares. And so it might be a bit challenging for students to break up the shape. The easiest way to break up the shape would be the way that we did in this example. However, if students were to break up the shape like this, it might be a little bit more challenging, just because they'll be able to say, okay, well, the length is 3 meters. However, the width, they might struggle with that. It's 4 because we have 2 here, and then we also have 2 here. 2 plus 2 is 4. So just keeping that in mind. And so for their fluency today, they are going to continue multiplying and dividing fractions. Have them use KCF to multiply by the reciprocal, just like we did yesterday.